For today's video, we're going to be looking at topic 6, the writing of chemical equation. So, at the end of this section, you should be able to interpret chemical equations with state symbol. You will learn how to write balanced chemical equation. Now, first off, let's take a look at word equation first. Now, what exactly is a word equation? Now basically, right, a word equation is an equation that is written in words. So anything equation that is written in words is a word equation. Now in chemistry, a word equation basically tells us what a chemical reaction is. Okay, so the word equation includes only the chemical names of the substances that are involved in the reaction itself. The substances that is written on the left hand side of the equation are the reactant. So these are the substances that will take part in the reaction at the start of the reaction. Then the substances on the right hand side of the equation are what we call the products. So basically the products are what is being formed at the end of the reaction. Okay, so these substances that are formed during the chemical reaction, we call them the products. Okay, they are the products of the reaction. And then in chemistry, right, we don't use an equal sign, we use an arrow. So basically this arrow means react to form. So for example, right, if you take a look at this reaction between sodium and chlorine, if sodium reacts with chlorine, it will form sodium chloride. So I can write that in the form of a word equation. So sodium plus chlorine will react to form sodium chloride. So this is the product of the reaction. These are the reactants of the reaction. Alright, so these are the reactants, and this is the product. In this case, you only have one product for this reaction, okay, but this may not be the case for all reaction. You can have two or more products that's being formed in a reaction itself. So this is what we call a word equation. It tells us what goes into a reaction and then what is formed at the end of the reaction. Now pause the video and do test yourself 1 now. Alright, are you done with the first 4 questions in test yourself 1? Let's check your answer. For the first question, you have sodium and chlorine gas react to form sodium chloride. So the answer is already given to you. Sodium plus chlorine, arrow, sodium chloride. Question number 2, methane reacts with excess oxygen to form carbon dioxide and steam. So methane plus oxygen, arrow, carbon dioxide plus steam. Third question, copper 2 carbonate decomposes to form copper 2 oxide and carbon dioxide. So copper 2 carbonate, arrow, copper 2 oxide plus carbon dioxide. And last but not least, ammonia gas is formed from the reaction between hydrogen gas and nitrogen. So remember, the reactants must come first. So you must put hydrogen plus nitrogen react to form ammonia. Ammonia is what is formed at the end of the reaction, so it must be on the right hand side of the equation. You cannot present it in any other way, okay? The arrow always point from left to right. Alright, so these are the answers for test yourself 1. So now that you have learned about chemical equation, word equation, sorry, we will now learn about the chemical equation. Now the chemical equation is the most important part of this chapter, so make sure you follow closely and understand what is going on over here. Now the chemical reaction or equation tells us what happens in a chemical reaction, okay, similar to a word equation. However, a chemical equation tells us more information about the reaction itself. Okay, so in a word equation, right, you only know which reactants and products are involved in the reaction. Okay, but for a chemical equation, it does more than this. It tells us what reactants and products are involved. It also tells us the relative amount of reactants and products used in the reaction and formed during the reaction. Alright, as well as the physical state of the reactants and the product. So there are much more information that can be obtained from a chemical equation compared to a word equation. So for example, if we look at just now the example on sodium reacting with chlorine to give me sodium chloride, this is the word equation. The chemical equation will be 2Na plus Cl2 to give me 2NaCl. So basically what I have over here is the chemical formula for sodium, chlorine and sodium chloride, and this number 2 in front over here and this 2 over here, this tells us the relative amount of the reactant to the product. So 2Na will react with 1 Cl2 to give me 2 NaCl. So these basically are the relative amount. Okay, and later we'll be looking at the physical state of the reactant and products. Now in a chemical equation, a balanced chemical equation must contain equal number of atoms of each element on both sides of the equation. Okay, so anything that occurs on the left hand side, the number of atoms for each of the element must be equal to the number of atoms on the right hand side. So when we first form an equation, right, it may not be balanced, so we will need to balance it. Okay, so the reactants, that what I've mentioned previously, is written on the left hand side of the equation. Products are written on the right hand side. So the chemical equation, right, in order for us to balance it, right, we will add a number in front of the chemical formula. So you cannot change the chemical formula of the reactants or the products. The chemical formula must remain the same. Okay, it must be the correct chemical formula. So for example, right, H2O is always H2O. You can't change it to H3O or H2O2. Okay. Then, if let's say I want to give more information about the reaction, right, I can actually include this thing called the state symbol. So for each of these substance, I can put a bracket at the back, and then I'll put a bracket S, bracket G, bracket L, or bracket AQ. So what does this mean? This represents whether or not this substance is a solid, gas, liquid, or aqueous solution. So I'll explain more of this in the later part of the chapter. So, for us to write a balanced chemical equation, let's take a look at the question that is given to you in your notes. If let's say we need to write a chemical equation for the reaction between hydrogen and oxygen to get water, how will we go about doing that? So the first step is to write the chemical equation for this reaction itself. So you know that hydrogen reacts with oxygen to get water. So you write down the chemical formula of the reactants and the product first. So first on, I have my hydrogen over here. So my hydrogen, chemical formula H2 reacts with oxygen, chemical formula O2 to form water, chemical formula H2O. So this is the first step. You write down the equation, you form the equation first. Okay, so once we are done with step number 1, right, we will need to try to balance the equation. So sometimes, right, sometimes the equation when you write it down, it is already balanced. So step number 2, we check to see whether or not the equation is balanced. So how do we check? Okay, we check by counting the number of atoms for each element on the left hand side and the right hand side of the equation. So this will be the left hand side of the equation, this will be the right hand side of the equation. So I will count. On the left hand side, I have 2 hydrogen atom, 2 oxygen atom. Right hand side, 2 hydrogen atom, 1 oxygen atom over here. Alright, so after counting, then if, let's say, if it is balanced, then I don't need to do anything. But if it is not balanced, that means it's not equal, there is no equal number on the left hand side or right hand side, then I will need to proceed to step number 3. So in this case, right, it is not balanced. Can you see? There is only 1 oxygen on the right hand side, but there's 2 oxygen atoms on the left hand side. So right, this is not a balanced chemical equation. I will need to proceed on to step number 3. So step number 3, we will need to try to balance the equation. So since just now I counted, right, and there is only 1 oxygen on the right hand side of the equation, I will put a number 2 in front of the H2O. This means that now, right, I'm multiplying this H2O by 2. So basically I'm forming 2 H2O molecule like this. Okay, but right, even if I do so, the equation is not balanced, because now there's going to be a total of 4 oxygen atom, 1, 2, 3, 4 on the right hand side of the equation. Okay, but on the left hand side now, I only have 2 hydrogen. So what can we do to balance the equation? So in order for us to balance the equation, I will need to put a 2 in front of the H2O over here. Okay, so by adding a 2 over here, now I will have a total of 1, 2, 3, 4. 4 hydrogen atom on the left hand side, 1, 2, 3, 4. 4 hydrogen atoms on the right hand side of the equation. Then for the oxygen, I have 1, 2, 1 and 2. So now I have a balanced chemical equation. So this is my answer for the reaction between hydrogen and oxygen to form water. Now, if, let's say, the question asks you to add in a state symbol, you may add a state symbol to indicate the physical state of each of the reactant and products. So these are the state symbols like what I've mentioned before. So in this case, right, hydrogen is a gas, oxygen is a gas, so you can put a bracket G, and then H2O is a liquid, so you just put a bracket L. Now this AQ simply means that it's dissolved in water, alright? If any substance is dissolved in water, we say that it is in the aqueous state. So for example, if I have sodium chloride and then I dissolve the sodium chloride in water, I will put a AQ beside the sodium chloride. Right? So these are the 4 state symbols. Please note the difference between aqueous and liquid state. Now for the aqueous state, right, the substance has been dissolved in water to form a solution. So for example, I have sugar. I dissolve in water to form sugar solution, or I have salt. I dissolve in water to form salt solution. Those are in aqueous state. But for liquid state, right, the substance is pure. So for example, I have water. Water is in the liquid state, or ethanol. Ethanol is in the liquid state. Or maybe I can have iron, right, and then I heat it until it reaches the melting point. Then beyond that, iron will melt to give me liquid iron or molten iron. Alright, so that is in the liquid state. So please don't confuse aqueous and liquid state. Now once you are done with this, you may proceed to test yourself number 2. Balance the following chemical equation by adding a coefficient in front of the different substances. Alright, pause the video and try test yourself to question 1 to 6 now. Now check your answer for question 1 to 7, sorry, of test yourself 2. Did you manage to get all this answer? We have come to the end of the chapter.